This video is presented to you by www.testprepadda.com. Dear students, in the previous session of heat and thermodynamics, I started the discussion of temperature measurement. In that session, I talked about liquid in glass thermometer. I talked about degree Celsius and degree Fahrenheit temperature scales. But dear students, different liquids have different expansion properties. So thermometer, liquid in glass type, show different readings for temperatures other than fixed points. Fixed points means ice point and steam point. But a thermometer where we use gas, a gas occupies same volume under same conditions of temperature and pressure. All the gases occupy same volume under the same conditions of temperature and pressure. But this is not true for liquids. In this session, I will talk about ideal gas equation and absolute temperature. Dear students, according to Charles' law, for a given mass of a gas, the volume of the gas increases or decreases by 1 upon 273.15 of its volume at 0 degrees Celsius for each degree rise or fall in temperature, provided pressure is kept constant. Means at 0 degrees Celsius, I say volume as V naught. Then at 1 degree Celsius, volume will become V naught plus 1 upon 273.15 into V naught. Volume increases by 1 upon 273.15 of its volume at 0 degrees Celsius for each degree rise of the temperature. If I ask minus 1 degree Celsius, then the volume will be V naught minus 1 upon 273.15 into V naught. Volume decreases here by 1 upon 273.15 of its volume at 0 degrees Celsius for each degree fall in temperature. In general, if I want to write at T degrees Celsius, volume will be written as V naught plus 1 upon 273.15 into T into V naught. If I take this V naught common, inside I get 1 plus T upon 273.15. Now if I ask you at what temperature this term becomes 0. It's very easy. If I write T is equal to minus 273.15, then this term will become 0. 1 minus 1. And that is why volume becomes 0. Now, you cannot imagine a negative volume. Volume of any substance cannot be negative. That is why this minus 273.15 degrees Celsius we say as the lowest possible temperature. Lowest possible temperature, and this is designated as absolute zero. Absolute zero, because here the volume becomes zero. And another point, in kinetic theory of gases, you will learn that kinetic energy is dependent on temperature. And here at this temperature, all movements will become zero. And that is why we call this as absolute zero. And on this basis, another scale that we call as Kelvin scale came into picture. Dear students, many of you may say that when we decrease the temperature of the gas, after one stage, the gas will be converted into liquid or solid. So this law will not be applicable. Then how can we say minus 273.15 degrees Celsius is the lowest possible temperature? For that, let me draw a graph between volume and temperature. If I draw a graph between volume, and temperature in degrees Celsius. At 0 degrees Celsius, we have said that the volume is V naught. Okay, and as temperature decreases, volume of the gas. If we measure volumes at few temperatures, let us say this, so it comes a straight line like this. Although we cannot reach to zero volume, but mathematically if I try to extend this line, it will cut somewhere here. And this is the temperature where we can say volume will become zero. Although practically not possible, but mathematically we can reach to this value. And this value comes as minus 273.15 degrees Celsius, and this is designated as absolute zero. And this way Kelvin scale came into picture, where we call this temperature as 0 Kelvin. So if I compare the two scales, degree Celsius and Kelvin scale, this is the steam point. This is the steam point. In degrees Celsius, it is 100 degrees Celsius. This is the ice point. In degrees Celsius, it is 0 degrees Celsius. And here if I say minus 273.15 degrees Celsius, absolute zero. In Kelvin scale, this point is written as 0 Kelvin. So 0 degrees Celsius will be written as what? 273.15 Kelvin, and 100 degrees Celsius will be written as what? 373.15 Kelvin. So in general, if I write T degrees Celsius in Kelvin, it will become T plus 273.15 Kelvin. So temperature in Kelvin is actually temperature in degrees Celsius plus 273.15. My point is clear. Dear students, here we have written volume at T degrees Celsius is equal to volume at 0 degrees Celsius into 1 plus T upon 273.15. Here if I write this in this manner, 273.15 plus T upon 273.15. This 273.15 plus T is what? Temperature in Kelvin at T degrees Celsius. So in place of this I can write T means temperature in Kelvin at T degrees Celsius upon 273.15. What can we write? 273.15 is the temperature in Kelvin at what degree Celsius? 0 degrees Celsius. So I can write this as T0. As a result, I get Vt upon Tt is equal to V0 upon T0. Now, whether it is V1 upon T1 or V2 upon T2, it is going to remain same, V0 upon T0. This way we say V upon T is equal to constant, means V proportional to T. Dear students, while doing this, we have kept pressure constant. We have kept pressure constant. That is why a thermometer which uses this concept of measuring volume with change in temperature, those thermometers are called constant pressure thermometer. Constant pressure thermometer. You got my point? Dear students, now I will talk about constant volume thermometer. According to Boyle's law, for a given mass of a gas, the volume of the gas is inversely proportional to the pressure of the gas provided temperature is kept constant. Means V is proportional to 1 by P, or I say V is inversely proportional to pressure. Here temperature and mass, these two things are kept constant. In Charles' law we have said that volume is directly proportional to temperature in Kelvin. Here pressure and mass was kept constant, right? And there is one more law, Avogadro law, which says equal volumes of all the gases contain same number of molecules or same number of moles under identical conditions of pressure and temperature. So volume can be written as proportional to number of moles if pressure and temperature are kept constant. Now if I combine these three, I get V proportional to 1 by P into T into N, or I can write this as V is equal to, since if I remove this proportionality sign, I am writing equality sign, I have to write a proportionality constant, that I am writing here as R. So the equation becomes PV is equal to nRT. Sometimes in physics we write this as PV is equal to mu RT, where N or mu, N is what? Number of moles. Number of moles of the gas. And for 1 mole we can write PV is equal to RT. This is for 1 mole, and this equation is known as ideal gas equation. Here the value of R is 8.314 joule per mole per Kelvin, or 2 calorie per mole per Kelvin, and one more value of R, that is 0.0821 ATM liter per mole per Kelvin. So these are three values of R according to units of R. Dear students, this equation PV is equal to nRT helps us in measuring the temperature in a constant volume thermometer. Constant volume thermometer. If I take this N as constant, if I take this volume as constant, pressure will be proportional to temperature. So if I draw a graph between pressure and temperature, then the graph comes like this. And here we can clearly see mathematically at 0 Kelvin, the pressure of the gas is 0. Or if I draw a graph between pressure and temperature in degrees Celsius, then at 0 degrees Celsius, if I assume pressure as P naught and we find pressure values for some temperatures, and on extending this line, the graph cuts the x-axis or temperature axis at this point. This is minus 273.15 degrees Celsius, which we call as absolute zero. All movements will become zero at this temperature. and the scale which use this concept is known as constant volume thermometer scale. Dear students, please note here we have written ideal gas. This equation is obeyed by ideal gas. Real gases deviate from ideal behavior and they obey ideal behavior only at low pressure and high temperature. Now let me take few questions here. Here the question says the pressure of a gas in the bulb of constant volume gas thermometer is 73 centimeter of mercury at 0 degrees Celsius. This is the unit of pressure, centimeter of mercury, or we say of mercury, and 100 centimeter of mercury at 100 degrees Celsius. If at room temperature pressure is 79.5 centimeter of mercury, then find room temperature. If I draw a graph between pressure and temperature in degrees Celsius, in the question it is given at 0 degrees Celsius, the pressure is 73 centimeter of mercury, and at 100 degrees Celsius, the pressure is given as 100 centimeter of mercury. So if I draw, this is the straight line. Okay, now this straight line I can write the equation using y is equal to mx plus c. Here y I will write as p because y-axis, and x I will write as T, temperature in degrees Celsius, into m. M is the slope. How do we find slope? If I say this as theta, then tan theta will be what? This length upon this length. It will be 100 minus 73. 100 minus 73 upon this length is what? 100. So it comes as 27 upon 100. If I substitute here 27 upon 100 plus what is the intercept? Intercept is 73. This way we get the relation between pressure and temperature. Now in the question it says pressure at room temperature is 79.5. So if I substitute here 79.5, I will get the room temperature in degrees Celsius, and the value will come like this: 79.5 minus 73 upon 27 into 100. If you solve, the value comes as 24. So 24 degrees Celsius is the room temperature as per the given data. My point is clear? Here the question says convert 0 Kelvin into degree Fahrenheit. We have just got the comparison of degree Celsius and Kelvin scales. I will show you. At steam point we say in degree Celsius it is 100 degrees Celsius, and 0 degrees Celsius ice point, and lowest possible temperature minus 273.15 degrees Celsius. In Kelvin scale, this point we have set as 0 Kelvin, and here 273.15 Kelvin, and here 373.15 Kelvin. Please note here we do not mention degree. Now, if you want to get another scale or you want to compare with Fahrenheit scale, here we know steam point is 212 degree Fahrenheit and ice point is what? 32 degree Fahrenheit. Question says get this value. And we already know the relation between temperature in degree Fahrenheit and temperature in degrees Celsius. 32 plus 9 by 5 temperature in degrees Celsius. So if you want to convert this 0 Kelvin into this Fahrenheit, you can convert this minus 273.15 degrees Celsius into Fahrenheit. The two will give the same value. So temperature in Fahrenheit at minus 273.15 will be 32 plus 9 by 5 into minus 273.15, and this value comes as minus 459.67 degree Fahrenheit. So what can we say? 0 Kelvin when converted into degree Fahrenheit, it is minus 459.67 degree Fahrenheit. My point is clear? Dear students, let me tell you that electrical resistance R of a metal wire increases monotonically with temperature. So this electrical resistance can also be used to define a temperature scale. If I say R naught is the electrical resistance of metal wire at ice point, and R100 as the electrical resistance of metal wire at steam point. So if I draw a graph between electrical resistance and temperature on this scale, ice point I will take 0 degree, and steam point I'll take 100 degree. So at 0 degree the electrical resistance is R naught, and at 100 degree the electrical resistance is R100. So the graph will be like this. Now what relation we can write? Y is equal to mx plus c. In place of y we can write here r, and in place of m we can write slope. Slope is, let us say, theta. So tan theta will be what? This length upon this length. This is what? R100 minus R naught, R100 minus R naught upon, what is this? This is 100. So this is the slope, R100 minus R naught upon 100, and in place of x what will you write? Temperature T, plus what is the intercept? R naught, and on this basis the temperature will come as RT minus R naught upon R100 minus R naught into 100. So this way we get the temperature by measuring the electrical resistance. And one of the examples of this thermometer is platinum resistance thermometer. Platinum resistance thermometer. Now I will take a question here. Here the question says the resistance of a platinum resistance thermometer at the ice point and the steam point are 80 ohm and 90 ohm respectively. Find the temperature at the platinum scale at which the resistance is 86 ohm. Ice point and steam point measure 0 degree and 100 degree respectively. Dear students, we have just derived the relation between temperature and electrical resistance as this. Now if I substitute values at temperature T, the electrical resistance is 86. Alright, 86 here minus at ice point, which is 0 degree, the electrical resistance is 80 upon at steam point it is 90 minus 80 into 100. So the value comes as 6 upon 10 into 100, and that comes as 60 degree. So at 60 degree at the platinum scale, the resistance is 86 ohm. Dear students, this is all about temperature measurements. We talked about different scales. We talked about the properties which are used to define the temperature scale, and we also talked about absolute temperature scale. Dear students, from the next video session, I will start the discussion of thermal expansion, another part of heat and thermodynamics. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.